So we're going to talk about something called percentiles today, which you've probably heard when you've gotten things like the PSAT and SAT results back. And so the definition of percentile we're going to use is the percent of values that are equal to or below a given value. This equal to is going to be important for us as the AP statistics clearly defined percentiles this year for us, which is different than what it has been in the past. So if we look at this stem plot, it's showing 30 Major League Baseball teams in 2016, and it says the Detroit Tigers won 86 games that year. What is their percentile rank? So what we want to do is add up the number of teams that had equal to or less than the number of wins. And when we do that, we get that there were 20 teams that had 86 or less games won out of a total of 30, which gives us 0.67. So their percentile would be the 67th percentile. Conversely, the number of wins for the Texas Rangers is at the 90th percentile. So what that means is that 90% of the teams have fewer or the same number of wins as the Rangers. So what that would mean is if we're at the 90th percentile, 90% of 30 would be 27. So Texas is above 27 of the teams. Therefore, they would have had to have 95 wins for them to be in the top 3 of those teams. Next, we're going to look at presidential ages. Once again, another stem plot. So I'm just going to verbally describe some things from this using our SOCs. This graph would be roughly symmetric. We're centered around 50, in the 50s for the age. It has a spread of about 28 years, and it doesn't appear to have any outliers. So part B says, Barack Obama was 47 at the time of his first inauguration. What was his percentile rank? So we want to look and see how many people were the same as or less than his age. So that gives me a total of 6 presidents out of the 45 we have listed here. So 6 out of 45 would be 13.3%. So the 13th about percentile. So that is pretty relatively young. We also are going to learn about something you probably haven't heard of called ogives, not ogives, ogives. And an ogive is a cumulative frequency or cumulative relative frequency graph. And it allows us to see the relative standing of an observation. And especially here, although always, we want to pay attention to the axes. So if we look at trying to make an ogive from the presidential ages we just looked at, the first thing we do is collect the number of frequencies for each interval that we have. So for instance, we have 2 presidents who were age 40 to 44, and we go through and fill those out. Our next step is to then find the cumulative frequency. So the first one is 2, and then this 9 came from 2 plus 7. The 22 came from 2 plus 7 plus 13, etc., etc. And then you change those two percentages and graph those. Here's what that graph looks like. So the leftmost point is plotted at a height of 0%, which is saying that no presidents took office before age 40. The next point is plotted at a height of 4.4%, which means that 2 presidents were inaugurated before 45 years old. And you see we have the steepest increase here between 50 and 60 because that means that's where the most number of presidents were when they were inaugurated. And the rightmost point is up here saying that 100% of presidents took office before age 75. So if I want to circle the point 60 and 75.6, let's explain what that means. it means that 75.6% of the presidents were younger than the age of 60 at the time of inauguration. If instead we want to estimate and interpret the 35th percentile of the distribution, we look on the left side of the graph and go to where there's approximately 35 on that y-axis and see where it's crossing my curve, which looks like roughly between 50 and 55, so we can say about 52. So the 35th percentile is about 52, and the interpretation of that would be that about 35% of presidents were younger than age 52 when they took office. So if we want to estimate the 5-number summary of this distribution, then remember that's going to be our minimum, which is 40. Then we have quartile 1, which would be where we have about 25%. So coming over here, that's about at age 51. Our median, that means we're looking for 50 on our cumulative relative frequency, so about 55 or so, 55, 56. Quartile 3 means we're looking for where that is going to be 75%, which we actually already estimated as 60, and we have a max already discussed of 75. So let's look at another example. Estimate the percentage of shoppers that spent less than $20. So that means I need to go on my x-axis to 20 and then look to the left to see where that's crossing, which is about 28 or 38%. What if instead we wanted to estimate the percentage of shoppers that spent more than $40? We would go to $40, go over to our y-axis, and we'll say that that's about 68%, but we need to read the question again. It said more than, so we want to do 100 minus 68%, which would be 32%. The percentage of shoppers that spent between $30 and $60. So we want to go to 30, go across, go to 60, go across, and now we're going to subtract those. So I'm going to estimate the top one is about 90, and the next one, let's just say, is about 57, and that's going to give me 33%. And these are all approximate since obviously we have to eyeball this. A person at the 40th percentile spent approximately what amount? So now I'm looking on the y-axis to 40 and seeing where that crosses my graph, which is going to be at about $25. And here's a graph for the last question that you have on your paper.